welcome back to the Analyst Lens. So I'm just starting a new playlist on the EDA, which stands for the Exploratory Data Analysis. So this video is all about starting a brief introduction about what is EDA, how it is important, what are the briefly steps followed in the process of EDA, why it is important, and we will just see the real life example where we use the EDA. So basically, EDA is a process we generally use before building a machine learning model or testing the data. So EDA just not only include the cleaning and all, it is more about the data re-engineering and the clearing the data. So in this playlist we will just get familiar what is EDA and see how it will helps. Once we are done with the EDA, we will get back next to the building model on the basis of the data we get after cleaning and sorting the data. So we will just start the video with this. Thank you. So in the first step of exploring the EDA, we will just get familiar with the term EDA. So in layman language, I can say that EDA refers to the method of studying and exploring record sets to apparent their predominant trait, discover patterns, locate outlier, and identify relationship between the variables. So here we identify the outliers. So basically all we know that outliers are the extreme values in the data which basically manipulate the data and give us a result which is not correct. So the next one is identifying relationship between the variables. So variable can be independent and dependent variables. Moving forward, EDA is normally carried out as a preliminary steps before undertaking extra formal statistic analysis or modeling. So all as we know that before building a machine learning model like linear regression, logistic regression, multiple linear regression, decision tree and random forest and all, we need to clean the data and ensure that there is no any outliers in the data so that we can get the clear or correct result. So in EDA we have general steps like data collection. In the data collection we just gather the relevant data sets, understand the data like what are the traits in the data. So the second step is the data cleaning. As we all know that the data must be clean in order to generate the correct insights after the data. The third step is includes the data exploration. So in this step we just examine data structure, compute summary statistics. The next step is a feature engineering. As the name suggests, it involves in creating new feature if needed or transforming existing features. So the next one is correlation analysis. So in the correlation analysis we will just find out the relationship between the dependent and independent variable and just test how one change in independent variable result in the change in the dependent variable. After we're done with all of this, we just move to the next step, that is data visualization. So the data visualization help us to see how the data is correlated with each others, like how dependent variable affect the independent variable and vice versa. The next one is the statistical analysis. So statistical analysis involves conducting hypothesis testing if applicable, also involves extracting statistical measure, and as the last step is reporting insights. Basically it involves summarizing all the insights we get, whether in the form of visualization, whether in the form of the summary like statistical like correlation, f2 square, mean squared error, mean squared percentage error, whatever we get while exploring the data, we will just get a report out of that and present it in the form of the insights. Once we are done with this, we will see why EDA is important. Is this necessary or not? So now as we all know about the basic definition of the EDA, like what it is, what it involves, we will get familiar with why EDA is important. Like, is it necessary to do EDA before moving forward, like building machine learning models like linear regression, multiple regression? Is it really needed, or is it help in building the model more effective or more efficient? So we all know that before building a model we need to clean the data so that it can generate the best or better insight than the other. We need to perform some feature engineering like putting some new functions or changing the existing one, and also involves the correlation, which involves the seeing is there any relationship between the variable, like is there any relationship between dependent and independent variable, We can measure this by F2 score and mean squared error, or also by visualizing the relationship between the independent and dependent variable. Like plotting a scatter plot, bar chart, line chart will help us to measure these relationship. Also, it involves data segmentation, which involves dividing the data into different groups, so that we can see that how the data is correlated. Also, it helps in the hypothesis generations to check whether the relationship between the data is correct or not. And also it helps in the data quality assessment, so to see whether the data is really useful while building a machine learning model, or it just waste. So let's see some of the basic, or we can say some of the foremost goal why we perform ED. So let's get familiar with some terms which we'll get while the coding part of the EDA, while really performing the EDA in Python. So the first one is the data cleaning. So the data cleaning in EDA involves examining the information of error, like where we get some errors in the data, also lacking values, like if we have some missing values or some extreme values we can say. And also it also include technique like a record imputation, managing missing statistics, and figuring out and getting rid of outliers. Like we can use the drop na command to get rid of the outliers or the error values. The second one is the descriptive statistics. So descriptive statistics utilizes precious records to recognize the important tendency or variability. Like this, by performing the descriptive statistic, we will just get familiar with the data and also find out that is there any variability in the data, like is there any factor which create variation in the data. So the next one is the data visualization. So basically EDA employs visual techniques to represent the statistical graphics, which will help to identify the relationship between the variables, whether there is a positive correlation between the data or a negative, or there is no correlation between the data. And the next one is the feature engineering. So the feature engineering term is will occur in the coding path also. So the feature engineering allows for the exploration of various variables and their adjustment to create new functions. For example, if we need to create a new function on the basis of the existing variable, we can create them by using feature engineering. Also we can improve the existing functions by this. The next one is the correlation and the relationship. So as we all know that there is a relationship between the independent and the dependent variable, that's why we will build machine learning model like linear regression and logistic regression. So basically ED allows discover a relationship and dependencies between the variable, like how one variable is dependent on the other variable. So in this, techniques such as correlation analysis, scatter plot, and path tabulation offers insights. Like for example, by building a scatter plot, we will just get familiar with like whether the data has relationship between them, like independent variable and dependent variable are positively correlated or there is no relationship between them. It also involves data segmentation, like EDA can contain dividing the information into significant segment based on totality of sure standard or trait. Like for example, some of the data can be sorted. So the next one is hypothesis testing and data quality assessment, which will help in the EDA process. So that's it about the why EDA is really important. So the next part is types of EDA. So we all have the questions like why there is types of EDA. If we need to explore the data, we can explore this by one technique. So because the data have different aspects, or we need to explore the data and understand in various ways, so that's why we need to use the different types of EDA here. So basically reason behind using the different EDA can be comprehensive understanding, like the data can be of many types, like we have structured, unstructured, and semi-structured data types. So getting familiar with these data types, we need to perform different types of EDA. Also the complex relationship often involves complex relationship between the variables, like bivariate relationship. Multivariate analysis is used to uncover the insights between the data. Also, visualization. For example, humans are adept at interpreting visual information. Data visualization techniques like helps in quickly grasping the insights. Like whatever we get in the data, we can present it through the visualization, whether rather than by giving some numbers and all. So, and the next one will be the problem specific insights. Like by performing different types of EDA, we can generate insight out of data like semi structured, unstructured, and uh, multiple data, which can help to get the correct insights, also help the user to get familiar with the data. So let's get familiar with the different types of the EDA, which will help in getting insights and generating the visuals out of the data. So first I will just clear about the reason like why I am adding so much of text in this video is just because some of our viewers are also making notes about these, like because of their subjects involve some terms like univariate analysis, bivariate analysis, so it will be helpful for them to make notes out of this video. So the first type of EDA is univariate analysis. So explaining this sort of evaluation makes specialty of analyzing character variables inside the record set. It involves summarizing and visualizing an unmarried variable at a time to understand its distribution, relevant tendency, unfold, and different applicable records. Techniques like histogram, field plots, bar chart, and precision information are generally used in univariate analysis. So as the name suggests, univariate analysis is about the one variable. So getting familiar with the one variable, like how it impacts the whole linear regression model or any model we just build on that data. So getting familiar what are the trait of that single variable in the whole data and what are the pattern it shows in the whole data, which will be beneficial while building a model or forecasting its effect on the dependent variable. So the example of the univariate analysis can be making histogram of the distribution of ages in a dataset showing the frequency of different age groups. For example, if we need to represent the age group in a data, like if we have age groups like 10 to 30, 30 to 40, 40 to 50. So if we need to represent these types of data, so we will use the univariate analysis. And by this we can make the histogram which will represent the different age groups in the data and the distribution of that ages. Moving forward to the next type of EDA, which is bivariate analysis. So the next type of EDA is bivariate analysis. As the name suggests, bivariate is always about two variables. So let's read about the definition. Bivariate evaluation involves exploring the connection between the variable. It enables find association, correlation, and dependencies between pair of variables. Scatter plot, line plot, correlation matrices, and move tabulation are generally used strategies in bivariate analysis. As the definition suggests, when we need to find the relation between the two variables, we will use bivariate analysis. In early definition, we will just get familiar with the univariate analysis, which will use one variable at a time. In bivariate analysis, we will just see how two variables are independent, whether there is a correlation, association, or any dependencies between the independent and a dependent variable. So for examining this type of analysis, or by doing this analysis, we will just make scatter plot, line plot, correlation matrix to visualize the relationship between these two. The example of the bivariate analysis can be plotting scatter plot, comparing the relationship between R of studies and the exam scores. For example, if you want to know how much a person or a student will score if he or she will study for some sort of time. For example, if a student is studying 4 hour a day, he or she will get 90%. If a student is studying 6 hours a day, he will get 92%. So getting familiar with the relationship between the two variables, the variable is here is the time and the marks a student will get, is also involves in the bivariate analysis, which is a type of EDA. So moving forward to the next type of EDA. So as we are done about the basic definition of the univariate analysis, bivariate analysis. In the univariate analysis, we will just see about the single variable. In bivariate analysis, we will just see the effect of the one variable on the other variable, whether there is association or correlation between them. So moving forward, the multivariate analysis is all about the multiple variable in the data. So multivariate analysis extends bivariate evaluation to encompass greater than variable. It ambitious to apparent the complex interaction and dependencies among more than one variable in a record set. Technique inclusion of heat maps, parallel coordinates, aspects analysis, and primary component analysis like PCA, which we will get just familiar in the earlier video, used for multivariate analysis. For example, if we need to understand the basic relationship, or whether there is an association, correlation between the multiple variable. For example, if the price is our dependent variable, so independent variable can be the customer demand, customer satisfaction, or also the season, whether there is a winter, summer, or anything. So these are the multiple variable on the basis of which we can just suggest or identify whether there is a relationship between the dependent and independent variable. For example, we can just plot 3D plot exploring the relationship between income, education level, and job satisfaction, which are the multiple variable in the data, and which will have some sort of effect, or we can see the relationship between them. So by this way, we will just cover the multivariate analysis, which will help in the EDA processes. Moving forward to the next type of EDA, which is time series analysis. So the next type of EDA is time series analysis. As the name suggests, it's all about the time, like in monthly, yearly, or quarterly basis. So the definition is this type of analysis is mainly applied to statistic sets that have a temporal component. Time collection evaluation entails inspecting and modeling styles, trade, and seasonality inside the statistics through the year. Techniques like line plot, autocorrelation analysis, transferring averages, and ARIMA, which we will just see in the Python, like ARIMA or AROMA fashions, are generally utilized in time series analysis. For example, imagine just we have a data set representing monthly sales of retail store overall several years. We could perform like some sort of time series analysis to uncover trends, seasonality, and make prediction. For example, a store which will sell clothes, we can just have different types of data. Like in the winter, they make a sale of 12,000 in winter, and in summer he just made some sort of 13,000. So on the basis of the last year, or we can say some years of several years of data, for example 10 years of data, we will just make some sort of production prediction, like what are the minimum stock he or she need to keep in order to meet the expected demand. So these are some of the areas, or we can say ways, where we just use time series analysis in order to predict the demand of some sort of product on the basis of the several years of data. Moving forward to the next type of EDA, which is missing data analysis. So the next one is the missing data analysis. As the name suggests, is all about the missing data. For example, if we have the data of like employees, like they have multiple columns, like number of years from which the employee is working, what are the posts on which they are working, and the salary and all. If the some of the columns are missing, we can't just predict the model on the basis of this, or we can't just make some sort of machine learning model on the basis of some missing data. So getting familiar with the definition, missing information is not unusual issue in the data sets, and it may impact the reliability and validity of the evaluation. Missing statistic analysis includes figuring out missing values, know how the patterns of missingness, and using suitable techniques to deal with the missing data. Technique along with lacking facts, styles, imputation, strategies, and sensitivity. Evaluations are employed in lacking fact evaluation. For example, in earlier videos, I will just suggest you that if we have some missing values and the values are important, we will just take the average, or we can say some of the other methods. We just take average and put the value, replace the null values with that value. For example, if we have marks of 100 students, for example 100 students, some sort of marks like 50, 60, and along with it, and we have two missing values in that. So we will just take the average of all the marks and just put it in the place of the null values. So we'll just, by this we will just sort the null values by taking the averages. So by this way we just treat the missing data in order to predict the relationship between the dependent and independent variable, and helps in the building the correct model and generating insights out of that. So the other example of the missing data analysis can be like we have a data of like performance data of the employees, where there are missing values in the year and the experience column. So by this data we can't just build some machine learning model which will help in predicting the performance, as well as the some other criteria on the basis of the number of employees or their year of working. So we just first step will be the identifying the missing values, like where the missing and values lies. The second step can be finding out the reason behind that, like whether the relationship between the independent and dependent variable can be affected, and all. The third one can be identifying the pattern of missing values, like whether there is a informal or formal pattern between the missing values. Also we'll just make some strategies in order to handle the missing data, so the analysis cannot be impacted by the missing data. So this is all about the missing data analysis. Moving forward to the next one, which is the outlier analysis. So as the name suggests, outlier analysis is all about getting familiar with the extreme values. With the data have some lowest values, highest values, we will just impact the quality of the data, and which will be can be hurdle in while building a machine learning model which will predict some sort of dependency in the independent and dependent variable. It also affects the association, relationship and correlation between the data. So outlier analysis are statistic factors that are drastically deviate from the general sample of the facts. Outlier analysis includes identifying and knowledge the presence of outlier, their capability reasons and their impact at the analysis technique, along with the box plot, scatter plot, Z ranking and clustering algorithms are used for the outlier evaluation. So if we have a data, like for example data about the students marks and their hours of study, so if we want to predict the marks of a student on the basis of the hour they study, so we need a proper data about the students, like number of hours they study and the marks they get. So if a student study 2 hours and get a marks of 100, so this can be an outlier in the data because of the average student, because the number of students average who studying 6 hours a day getting some sort of 80 marks. So the student who get 90 marks while studying 2 hours is can be an outlier. Also student who will just study 11 hour and getting 40 or 20 marks is also an outlier in the data. So we just need to get aware about these outliers in the data and need to handle it in order to make a best linear regression model or logistic regression model which will help in predicting the values of dependent variable on the basis of some independent variable. So for visualizing the outliers, we will just use box plot which will highlight potential outliers in a data set. For example, if we have data about the employees performance and their satisfaction, so the box plot will just highlight the outliers we have in this data. We will just get familiar with the data in the coding part of the Python while performing the EDA. So moving forward to the next type of EDA, which is data visualization. So the last type of EDA in this video is data visualization. So as we know, the data visualization is all about getting familiar with the data in the form of visuals. Like I also like the data which have visuals. Like nobody likes to see large data set which have numbers. For example, if we have one sheet of data about the students and their marks, and we will just replace it by having a simple line chart. We will just represent the whole data, which can be easy to understand by all the people in the room. So data visualization is a critical factor of EDA that entails creating visual representations of the statistics to facilitate understanding and exploration. So data visualization will help us to explore the data, whether to see whether there is a pattern in the data sets, seasonal, and can be also helps in identifying there is an association or correlation between the dependent and the independent variable. And some of the charts which are used to find out the relationship or getting familiar with the data visualizations are bar charts, histogram, scatter plot, line plot, heat maps and other. So these are some of the charts, or we can say some of the techniques which will help us to get familiar with the data by visualizing it. So we'll just explore one by one. Like for example, histogram is used to visualize the distribution of student score in class, providing an overview of the performance pattern. The next one is the scatter plot. For example, we'll just create a scatter plot to explore the relationship between the temperature and ice cream sales, revealing the potential correlation. The next one can be box plot, which is used to show the distribution of salaries across different departments in a company, highlighting the median, quartile, and outliers. Heat map can also be used to visualize the correlation matrix of variable in a financial dataset, identifying the strong and weak correlations. Line chart is used to illustrate the trend in patterns stock over time, aiding to the identification of the pattern or anomalies. So these are some of the basic, or we can say some of the important ways how we visualize the data, and some of the ways we can just visualize data on the basis of the dependent and independent variables. I hope you like these type of charts and my explanation with these charts. Next we will see just some of the real life examples. We will just use EDA in order to explore the data, generating insights and also visualizing them in order to make them more realistic, and which will see some of the variabilities in the data and helps in understanding by all the people. So some of the examples of exploratory data analysis, like where we generally use the data analysis techniques, are so these are some of the basic areas we will just use EDA in order to explore the data, so that we'll just get identify whether the data have any missing values, outliers, and get rid of that in order to build a more realistic and ideal machine learning model, which will help in identifying the relationship between the dependent and independent variable. So we will go just one by one. So the first one is the professional sports, like football, cricket, and can be anything. So by using the EDA in professional sport, we can just analyze player performance statistics, team trends, also the game outcomes to identify patterns. For example, a sports team might use EDA to optimize player rotation based on historical performance data. For example, use if I want to use some sort of players data in order to make predictions, like which player will perform best in some sort of games, like whether like some player will perform best in national level, some player best perform in international, or some in state level. So by using the EDA, we will just identify which player will perform best in which level, like whether the player will perform best in state, international, or the national level. So by using EDA, we can utilize the performance as well as the strategies of the player in order to succeed in the matches. So coming to the next one, which is healthcare. So basically in healthcare, EDA can be applied to healthcare data to understand the patient demographic, treatment effectiveness, and disease trends. For example, a hospital might use EDA to identify factor influencing readmission of the rates. So for example, during the COVID, so basically healthcare sector used the data of the patient in order to assess whether there is a common factor in all the patients who are getting admitted for the COVID, by which the data will help the hospital as well as the government to identify the areas where the COVID is emerging. So by this way, EDA can help in the healthcare too. So the next one is the marketing. So basically EDA is in marketing to identify the customer behavior, in which EDA helps in analyzing customer behavior, preferences, purchasing pattern. For example, a company might use EDA to identify key customer segment and tailor marketing strategies accordingly. For example, so some of the brands use market segmentations, like the we can take example of the luxury brands like Rolls-Royce, Louis Vuitton, and Armani, Gucci. So these are the brands which use market segmentation to segment to target their potential customers, like some of the customer who want luxury. So these are the brands who will prefer luxury customers. So the next one is hospitality industry. So basically in hospitality industry, EDA can be used to identify the satisfaction level of a guest. For example, EDA can be employed to analyze feedback and satisfaction score. For example, a hotel chain like Oberoi's, Radisson and all might use EDA to identify common themes in guest reviews and improve overall customer experience. For example, like OYO use satisfaction scores of a customer, on the basis of which they can improve their services they offer to the customer in order to increase the chances of a customer will be stay in the OYO. So the next one is the fraud detection. So EDA can also be used in identifying any fraud in the transaction, which helps the user to stay safe. So in transaction analysis, basically EDA can help in identifying unusual patterns in transaction. For example, EDA is used to detect anomalies and potential fraudulent activities. For example, such as if a user will spend with a normal pattern, and if suddenly the pattern of spending will change, the EDA can identify any fraud and will allow the user to block his or her account, which will protect her data. So the next one is the retail sector. So basically in retail sector, we can use EDA to identify the sales trend. So basically in EDA can be analyze sales data to identify trends and seasonal pattern. For example, a retail store, like can be anything, might use EDA to optimize inventory management based on historical sales data. So coming to the reason or the factor why you guys will choose this playlist or watch this playlist over others can be like regular updates, like we will perform regular EDA on the dataset available in the Kaggle and post those videos on this playlist. Also, if you have any queries like why we put this command on the Python, why we use this chart and all, you can put these queries in the comment box and we will try our best to reach you. And the other one is instant reply. Basically we will just see the comment and reply you by anyway. And the last one, the quote is, one video means you are one step closer to the become a business analyst or the data analyst. Like this playlist is will help the analyst aspirants, like the one who want to become the business analyst or the data analyst. This playlist will surely help you to get closer with your job or a dream job by polishing your skill set, like how to perform EDA, how to perform some sort of machine learning algorithms and all. So this is all about the video. We will start the coding part in the next videos. So hope you guys like this video. So please like and subscribe this video, please.